This video has several solved Class 1 two-dimensional problems, two-dimensional kinematic problems. I will, you will see as I go, this is a little rough in that I'll make mistakes every now and again, but I'm not going to take the time to edit it and make it perfect because I'd much rather trade that off and do more problems for you than have some that were just absolutely letter perfect without me stumbling in the middle. Second thing I need to say as preamble is that if anything I say is confusing, then you are more than welcome to pause and kind of process what I said or back up and hear it again. The main advantage of these is the ability to go through them multiple times. So that said, let's get started with the first kinematic problem we're going to solve, and it is this. Wiley Coyote puts on a pair of roller skates and then backs up into a large spring. I think we've all seen that cartoon. When the roadrunner passes him, he releases the spring. All is going quite well until the road makes a sharp left. The roadrunner made the same sharp left. However, Wiley Coyote made a straight. That is, he went off the edge of a cliff. It says the road hugged a cliff, so he found himself in midair. The cliff dropped 147 meters to the canyon floor. If Wiley was traveling at 37 meters per second when he left the road, how long did it take him to hit the ground, the floor of the canyon, and how far from the base of the cliff was he when he landed? Ignore air resistance and the time it takes for Wiley to hold up the sign that says Yikes. Never have figured out why in these cartoons it takes a few seconds for physics to kick in, but it takes a few seconds for physics to kick in. We're going to ignore that. This is a Class 1 problem. There was no launch angle. You launched from some altitude, some height, but you did not. You launched perfectly horizontally. That is, it did not say he, jumped at the last minute or he was on a pogo stick or any of that. So, Class 1 problems can be solved. I'm going to tell you in 2 steps. You'll see that's a little more work than that, but really they are: step 1, find the time needed to fall to the ground. We know how high up in the air he is, right there, 147 meters, and it does not matter how fast he is going horizontally, assuming he leaves horizontally. It does not matter, any of those variables matter, except that he's 147 meters in the high in the air. It is just like him dropping a rock, or let's say it this way, dropping a Wiley Coyote with no horizontal velocity, just dropping him off a cliff that's 147 meters high. That's step 1. Step 2 is, once we know the time, we're going to use that to find out horizontal motion. So as you can see, I've drawn us a little picture here. See if I can get that in the shot. That's pretty much it. You're going to lose a little out of the top of the shot, but that's okay. He is 147 meters in the air. This red path is his trajectory. He's going to land right there. And the question is, how far out here does he? Well, this calls for a kinematic chart, don't they always? Let me get us one up here. All right, here's a kinematic chart for us. Let's fill out what we know and figure out where we go from there. We're going to do the vertical part first. That is, we're going to fill out the vertical part of the chart first. How high is he? Well, the problem said 147 meters. How long does it take him to go along the trajectory? Well, we don't know yet. That's actually one of the things we're trying to figure out. What is his starting vertical velocity? Here's an area where a number of students kind of struggle. He has velocity, but it's all horizontal. Think of this as if he just stepped off the edge of the cliff. At the moment he steps off, his vertical velocity is 0 meters per second. It will get bigger than that, but that's where it starts. His velocity later would be how fast he's going vertically when he hits the ground. That would be the same vertically regardless of whether he has horizontal velocity or not. But as it turns out, we don't know that number, and we don't care about that number. We have not been asked yet, so that's going to be what we ignore. And then what about his acceleration? Gravity works up and down, so his acceleration is 10 meters per second squared, and that's everything we know vertically. Now we know 3 things there: displacement, starting velocity, and acceleration. So we should be able to solve that. We'll do that in a moment. Let's figure out what we know horizontally. We don't know his displacement. That's what we're wanting to know. That's this horizontal blue dotted line over here. We're about to know his time. His velocity horizontally when he started the problem was 37 meters per second. And of course, there's no acceleration horizontally. It takes forces to make acceleration. There's a vertical force, we call it gravity. There is no horizontal force working on this. He had attached himself to a spring. The moment he stopped touching the spring, he stopped accelerating. So he was in constant velocity flight. In any case, all right, so turns out while we know velocity later horizontally, that is, there's no acceleration, it's going to continue to be 37 meters per second, we're going to act like we ignore it, and that will give us a track to run on. So that said, let's solve the vertical part of the problem first. I've got to scroll down just a little bit. And we're ignoring V later, which means we need to use Violet. There's Violet, and you'll recall that Violet is a booger to solve for time. She's a booger to solve for time if both terms aren't 0. And in this case, we're lucky in that the first term here, we're talking vertical. So let me write that here just to play it safe. So no one forgets. The good news is that this term is 0. It's 0 because vertically starting velocity is 0. See there? So this term goes away, which reduces Violet to this, which is much easier to solve for time. As a matter of fact, let me blow that up a little bit. That's a little hard to see. There we go. Solving for time is a fairly easy thing. Here it is. And all I have to do now is substitute in my the particulars of my problem, and I'll be able to figure out the time. Let's do that briefly. Let's see, and I can't get all this on the screen at the same time because that would be too easy. There we go. We can cheat it a little bit. The 2, this becomes 147 meters. Acceleration is 10 meters per second squared. And then all I have to do is work that out, which I'm going to do on a calculator. I recommend you do the same thing. That is, you don't have to check my math, but you may have the ability to take square roots in your head, but I wouldn't recommend it. When I work that out on my calculator, it comes to be the square root of 29.4. When I take the square root, it is 5.42 seconds is the amount of time that it takes Wiley Coyote to hit the ground. So that is the solution to question 1 right here. How long did it take? 5.42 seconds. Okay, I'm going to erase all this so that we can still keep our thing in the shot, and I'm now going to solve the horizontal problem. Well, again, I need to use Violet, so let me get Violet out here. There's Violet, but in this case, the second term is 0. Because horizontally, acceleration is 0, then the second term of Violet goes away, and we're looking for distance, so displacement that is, so this comes pre-solved. I love it when that happens. So, let's see what we can do to solve that. This becomes... this becomes 37 meters per second, and time is what we just found out in part A, 5.42 seconds. When you work all that out, which I will do on a calculator, it comes out to 200.54 meters, and that's how far he landed. That's this number right here. We'll put it in our kinematic chart just for completeness sake. And we are done with this problem. Was no big thing. Recapping, find the time to hit the ground. Knowing that, find the distance it will travel in that amount of time. That's all there is to this type of class 1 problem.